Yeah. Hello everyone. Now we are continue our material of economic and business mathematics about matrix. Let me share to you the material first. I just share my screen. So here you go. Yeah. Matrix. This is not a movie. Yeah. Okay. So as we know, maybe all of you already learned about matrix when you were in high school. Matrix is any rectangular array of numbers surrounded. So this is the matrix. Usually matrix has an order, or in Indonesian language we call it as ordo. It stands from rows times column, row and column. So every matrix has an order, row and column. Row times column. Row is the horizontal part and column is the vertical part. So in this case, an example, so we have two row. This is row 1 and row number 2, and this is column number 1 and column number 2. So we call this matrix has an order 2 times 2. How about this one? We have only one row with 3 columns. Column 1, column 2, and column 3. So we call that this matrix order is 1 times 3. Don't be confused. This is 1 times 3 matrix, not 3 times 1, because the first order show the number of rows. Then the second part is number of columns. And as we know, we have some common bracket for matrix. The first one is the bracket like this, or the usual bracket, like bracket number 2. This one is the first type, this one is the second type, just the common bracket. And the last one is double, bracket with double line, like this one. But you cannot write or type bracket with only one line, because this is belongs to determinant. Or in this case, this is belong to determinant, the number of matrix or the value of matrix. We will learn about it later. So you can do or write in this type of bracket. In common mathematics, usually we also use this bracket as an absolute to show an absolute value. So whether the negative or positive result, it will be positive. That's called as absolute, or one straight bracket line. Yeah. This is the usual matrix, but we also have the matrix that called as vector. Vector actually is the matrix, but the requirement, or the matrix called as vector because it only has a column or one row. Only one column or one row. This is the example of a vector. This is so we have like so many row with only one column. Has a column, only one column. On the other hand, in the U accent, we have one row with some column. Both of them are called as vector because only have one column or one row. The other type of matrix is called as matrix identity. For the matrix identity, the number of column must be equals to the number of row. So for the first order, this is 2 times 2, and for this one is 3 times 3. So the number of column must be equals or the same as with the number of row. And see the identity or the most important part that makes this matrix called as identity matrix. So every part has one as the value or identity 1001, 100, 0100001. If you see it, the diagonal, this must be filled with 1 as the value. This is called as matrix identity. We will learn or discuss about multiplication later, so we just leave it as long as the most important thing in this slide is I just want to let you know that this is the matrix identity, the type of matrix. About the multiplication or the other operation of matrix, we will discuss it later. And then beside matrix identity, we also have the other type of matrix that called as matrix zero. Like the name, all the value in that matrix is 0. Okay. Now we are going to learn or discuss about basic matrix operation. There are several basic operation of matrix. The first one is talk about addition and subtraction, and the second one is multiplication. And we are going to learn there are several types or several multiplication in matrix operation. The matrix can multiply with scalar or constanta, and the matrix can be multiplied with the other matrix and also with the vector. The second one of multiplication matrix, this is very common. So in terms of matrix operation, we have to understand about the second one, the multiplication of matrix. This is the key of matrix multiplication. The matrix multiplication, the order must be m times n. So this is the number of row times the number of column. For the first matrix, if we are going to multiply it with the other matrix, then the second matrix must be has the n as the row 2, row number 2, column, row for the matrix number 2 times column for matrix 2. This is for matrix 1. And as I said, this is very important because the number of column in the first matrix must be the same with the number of row of the second matrix. Must be the same. Then the result is the first and the last number. It will become a new order of matrix result, m times p. We are going to try in the next slide. The first one, we are going to see or learn about addition and subtraction. This is very basic. For this operation, the order of matrix must be equal. This is the key. Must be equal. Why? Because for addition and subtraction, the addition or subtraction is working for the same row and column for the matrix. An example, we have matrix A and matrix B. Matrix A stands for this number. So it has, what is the order of matrix A? 3 times 2 or 2 times 3? Yeah, you're correct. 3 times 2. Why? Because there are 3 rows and 2 columns. 3 rows. 1, 2, 3. So the order of the matrix A is 3 times 2. How about the B order? The same one, because because this is very simple. Just by seeing it, seeing those matrix, then we can decide this must be have the same order, 3 times 2. 3 times 2. So the requirement to calculate the addition and subtraction is fulfilled. So it will not be a problem to calculate the addition or subtraction. A plus B. A plus B means the first row and first column will be added with the first row and first column in the second matrix. So 6 plus 1. 6 plus 1. And it will become the result of row number 1 and column number 1 too. For the row number 2 and column number 2, we have 4 and 3. So we just simply calculate it as 4 plus 3 here. 6 plus 1, 7. 4 plus 3, 7. That's the same thing happen. So if an example, I want to calculate or edit this matrix or this value, matrix A, with the third row and the second column. So for the A is 2 and for the B is 2. So 2 plus 2. It will be the result of the new matrix in the row number 3 with column number 2. The result is 4. And the result must be has the same order, 3 times 2. That's also happened in the subtraction operation. If A plus B means for the row 1, column 1, we add it with row 1, column 1 in B matrix, then for the A minus B, then A, row 1, column 1, minus B for column 1, row 1. 6 minus 1 become 5. For the last one, 2 minus 2. So 2 minus 2. For the row number 3 with column number 2. That's the basic operation of matrix for addition and subtraction. The keyword is the order must be equals. Okay. Now we are going to the next matrix operation. That is multiplication. The first one is scalar or constanta. This is very simple because for the scalar or constanta, we just multiply the constanta with all the number in that matrix. So next example we have A. Matrix A is 2, 1, 4, 0. Then if we multiply this A matrix with scalar, an example 5A. So we just multiply it 5 times 1, 2, 1, 4, and 0. And then multiply its value with 5. So the result will be 2 times 5, 10. 5 times 1 is 2. 5 multiplied with 4 is 20. 5 multiplied with 0 is 0. So this is the result for scalar matrix operation. For the vector, actually it has the same idea with the matrix multiplication, because vector actually is also a matrix, but it has only one row or one column. For the matrix multiplication, see, if an example we have A times B, so please remember this part. The second, or this is the first matrix, so matrix number 1, the number of column in matrix number 1, this one, n, must be the same with the matrix number 2 in the row number, or row, the total of row. So the column, matrix column 1, column in matrix 1 must be equals with row in the matrix 2 order. And the result is the front and the back, or row in matrix 1 and times column in matrix 2. M times P. M times P. This is the result. And this is the way we multiply the matrix. So A times B, an example. For the matrix A, we have A, B, C, D. The order is 2 times 2. 2 times 2 for the A matrix. And then for the second matrix, we also have 2 times 2. This is, yeah, unfortunately or fortunately has the same order. So this is very simple. 2 equals with 2. And the result will be 2 times 2, 2. So this will be 2 times 2. Deciding the result order is very important, because sometimes matrix operation is quite tricky, or maybe we can, if we are not do it carefully, or we have no idea about the result, then it's possible if we are making a mistake when we multiply or add the matrix, because there are a lot of numbers and a lot of like a part. So we have to be careful, and we have to able to imagine what is the result, what is the order in matrix result. And this is the way we calculate it. A, B, C, D. So A times B, or A multiplied with B, means for the first row and first column, we multiplied A with K plus B with M. A with K, B with M. A with K, B with M. AK plus BM. And then for the first row and the second column, we calculated A times L plus B times N. This will be the result of the first row, second column. Yeah. Maybe we are going to learn more we are going to learn easier if there is a number inside the matrix, not only the sign. So this is the matrix. We are going to, I want to explain to you first. So for the matrix A times B, the matrix A has an order. The order is 3 times 2. 3 row, 2 column. Row times column. So 3 times 2. Okay? 3 times 2. And for the B, it has 2 times 3. 2 times 3. You see? This one must be the same thing. So the number of column in matrix A must be the same with the number of row for column B. Then it can be multiplied. Otherwise, this is not possible to multiply. And the result will be 3 times 3. So the result of A times B must be 3 times 3. Look, 3, row 1, row number 2, row number 3, and 3 column. Column 2, column 3. 3 times 3. So the result is correct. This is how we imagine the result first and then see the details. The detail is for this one, 14, this is how we solve it. 1 and 3 times this one, this part. It will be first row, first column. So 1 times 2, 2. Plus 3 times 4, 12. The result is 14. For the last part, or row number 1, column number 3, this is the way you multiply it. This one with this row with this column. 1 times 6, 6, 6, plus 3 times 3, 9. 6 plus 9, 15. 15 will be the result of this part. See? And you can multiply it using the same way for the other number in that column, that matrix. Yeah. That's the multiplication operation of matrix. That's very important. So you need to learn about it very, very well. After the operation, we also have the transposition of matrix. The matrix is found by replacing row with column and vice versa. So replace the row with the column and the column with the row. An example, if we have A 2 times 3, then the result must be, then the A transpose, we can make it as A powered by T or A transpose. This is the way we write. Or we also can give the sign A accent. It means A transpose too. So A transpose or A accent. Column become row, row become column. 2 row become 3. 2 times 3. So 3 become row, 2 become column. If we see this part, so 2 row number 1 become column number 1. 2, 8 minus 7, it become this one. 2, 8 minus 7. Row number 2 become column number 2. 5, 4, 2. 5, 4, 2. This is what we call as transpose. Or if we see another from the other perspective or point of view, an example from the column side, so we have like this 2, 8 minus 7 and 5, 4, 2. Then if we see from the side of column, column become row. 2 and 5 become this one. 2 and 5. 8 and 4 become the second row. Minus 7 and 2, column number 3 become row number 3. See? So it's up to you. See from the side of column and move it or change it, replace it, become the row, or from row become a column. The result must be the same. And the most important thing is the order must be vice versa, or 2 times 3 become 3 times 2. 3 times 4 become 4 times 3, etc. So this is the exercise. The operation or the basic matrix operation, if we use it to solve or to calculate the implementation of economic and business, then this is the example of the question or how it applied in economic and business. This is the examples because it's a bit cut, so I try to just open it and maybe make it slightly bigger, or maybe just so it's difficult because this is the first example. If you see this one, let's see the description first. The monthly sales in thousand of burgers and bites. Burger called as B1 and bites as B2. But burger, I think we already know about the burger. If you see SpongeBob, then Krabby Patty is also a burger. And bites, there are several food that may be interpreted as bite. In some countries, bites mean like a food finger or the small food that you can eat per bite. Or in one country or the other country, like Canada, as I know, bite is like a small donut, small circle, like a ball donut, and then you can just eat it as one, just put one whole bite in one time in your mouth. So bite. So there are two products. The first one is burger B1 and bites B2 in 3 fast food restaurants. R1 as restaurant 1, restaurant 2, and restaurant 3. So R1 to R3 as follow. This is the combination. B1 means burger monthly sales in thousand. So burger 1 the number of sales of burger 1 in restaurant 1 is 35,000. So restaurant 1 can sell 35 of burgers with 42 of bites. This is for restaurant 2 for the bite and burger, as well as for restaurant number 3. Yeah. This is the combination. And there are 2 months of data. The first one is for January. So this is the data of sales in January. This one. And this part explaining the sales in February. So if you are asked to write down 2 times 3, 2 times 3, 2 row with 3 column, 2 times 3 order. Matrix J and F, January and February, representing sales in January and February respectively, then it is quite easy. You just need to transfer all the value inside this part in a matrix. So this is J matrix or January matrix, 35, 27, 13, 35, 27, 13. And for the second row, we have 42, 39, and 24. 42, 39, and 24. For February, we have 31 and 25, 17, 29, 3, 16. Okay, so this is the answer of A or point A. Just write down and create the matrix based on this explanation or description. And we have 2 matrices. That's it. And then this is actually how the operation, the simple operation of matrix used in application of economic and business. So if we have 2 sales, 2-month sales, January and February, then we can either finding the J plus F, the total sales in January and February, and also we can calculate the number of the different sales for 2 months with calculated J minus F. Because it has the same order, then we can calculate it particularly add or subtract it. 2 times 3, 2 times 3. The result must be 2 times 3 and 2 times 3, either plus or minus. Plus only, just plus it, 35 plus 31, 66. 27 plus 17, it will be 44. 13 plus 3, 16. For the first row. The second row, second row, 42 plus 25, 67. 39 plus 29, 68. 24 plus 16, 40. That's it. And for the J, January minus February, or if we want to see the differentiate between sales in January and in February, then just calculate it using J minus F, 35 minus 31, 4. 27 minus 17, 10. 13 minus 3, 10. 42 minus 25, 17. 39 minus 29, 10. 24, subtract it with 16, become 8. That's it. That's the application or implementation of the basic operation of matrix. We also can use or calculate or use the operation matrix, particularly in multiplication, to solve this next question. So, if it is known that a firm manufactures 3 products, P1, P2, and P3, there are 3 products. Product 1, 2, and 3. With it sells to 2 customers. There are 2 customers, customer 1 and customer 2. The number of items of each product that are sold to this customer is given by this one, this matrix. Customer 1, by product 1, 6. Product 2, 7. Product 3, 9. Customer 2, bought 2 for product 1, 1 for product 2, and 2 for product number 3. The firm charges both customers the same price for each product according to this one, P1, P2, and P3. And this is the charge at the same price. So this P actually showing the price. This is showing the quantity. And E in addition, yeah. And we have another CDE matrix. So find the following matrix products and give an interpretation of each one. A times B. A multiplied with C, C with D, A times C times D, etc. And then interpret each one. Maybe in your assignment, I will not ask you to interpret, but I will tell you an example to calculate the total revenue. Then you need to find out which one is the matrix of price and which one is the matrix of quantity. Then you know which matrix must be multiplied with which matrix to create or generate the total revenue. So AB, actually this is because P, price times quantity, this is also a total revenue. But in this case, because total cost charged to each customer, so it's quite it can be also seen by the point of view of customer, that the total cost that customer should pay. Actually, the total cost can be the total revenue from the seller side. This is the result. The total revenue received from customer is E in this case. So E times A times B. I think it is better if we try to calculate or multiply 1, so you can have perspective or point of view how we use the simple operation of matrix in the real business calculation. E is E times A times B. Let's see this one. E is total revenue. E, this one, okay. Let's just firstly, I want to separate the screen first and write down the question, and we are going to solve it. Okay. Wait a minute, just keep it. Okay, this one, move it here. Yeah, so I can see is it clear enough. Okay, here you go. Strike 2. So in this case, we are going to find out the total revenue. total revenue of the matrix. Revenue. The total revenue, based on this information, it will, or it can be generated from E times A times B. We have A is this one, A, B, C, D, E. Don't be confused. E, maybe I just write as an order. E is 1 and 1. A, that is the A, 6, 7, 9, 2, 1, 2, times B. See this one? This is the B, but there is a sign transpose. Let's see. Yeah, just, oh, okay. Maybe I just need to write it, and we will discuss and analyze it. Okay, so in this part, for the B, I have 100. I just want to show you where there is transpose sign over there. Because that is written in a purpose, not only a wrong things. Nah, okay, I just open it. Big. So this is how we calculate it. The first thing is we have to recognize the order first, order of matrix. So this one is, sorry, not 2, but 1 row, 2 column. So 1 times 2 order. This one is 2 times 3 order of matrix, and this one is what is this? 1 times 3. Yeah. Can you follow how we describe the order of this matrix? Okay. Yeah. So for the A times E times A, we need to solve it one by one. A times A equals to 1. 1 times 6, 7, 9, 2, 1, 2. This is, and this is 1 times 2 and 2 times 3. See the requirement. The first matrix row, a matrix column must be the same with the number of second matrix row, 2 and 2. This is equal. So the result will be the first times the last number of matrix. So the result of E times A must be 1 times 3 matrix. It will be derived from this one. 1 times 3. This is the result. So 1 times 3. So it's like this one. Blah 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 blah. 1 times 3. Okay. Let's try to calculate it then. Yeah. Okay. To calculate it, I just find the other color. Yeah, white. Back to white. First, this is how we calculate it. First row times first column first. This is 2. Wait a minute. It's not clear. If not clear, then we are going to be confused by ourselves. E times A equals to, this is for the first one, 1 times 6, yeah, plus 1 times 2. This is for the first one. Then one row 1 with the column 2. Here you go. 1 times 7 plus 1 times 1. For the last one, 1 times 9 plus 1 times 2. Okay, got it? This is the matrix. Just erase this. Wait a minute. This must be black. Yeah, just erase it. This is too long. Okay. So E times A equals to 1 times 6, 6 plus 1 times 2, 2. 6 plus 2 equals to 8. 7 plus 1, 8. 9 plus 2, 9, 10, 11. This is the result. 8, 8, 11. And if we see it, then we are going to see the result is 1 times 3. The result order is 1 times 3. So it's correct. Okay? This is keep us not confused about the matrix. This is only for the first matrix. We are not finished yet because we need to calculate the A times the E times A with the B now. B. Okay? We have B. This is the B. B times B. See? The B, we cannot just calculate the B with this number. This number is 1 times 3, right? So for the B, maybe I just, sorry, this one. B is 1 times 3. And we have A, and A, like this one. A and A equals to 1 times 3. And if we just calculate it with this B, 1 times 3, that it is impossible or not possible at all, because see the requirement, this one is not equal. Not equal. 3 and 1. No, we cannot calculate or multiply it. That's why there is a T here. T means we need to transpose it. So if we want to find the A, E times A with B, EAB, then maybe I just erase this part, this one. Oh, sorry. I just erase this part because we have done with this multiplication. And I want to explain the next. Okay, just be patient. It won't be long. So the most important thing or the keyword is see or find the order first for the matrix multiplication. And then you need to compare the requirement and see or decide the result. So E times A times B equals to this one, 8, 8, 11 times B. So you have to change the B from 1 times 3 become 3 times 1. Row become column, 100, 500, and 200. This one is B. So this is to make you not confused, A times A. This one is 1 times 3. This one is 3 times 1. This is the B. And compare it. Okay, 3 and 3. Yeah, it's correct. 3 and 3. This one the same thing. And the result must be 1 times 1. So let's multiply it. So A times B equals to, yeah, maybe I just erase this one because, sorry, not that one. Yeah, this one. Actually, this is very simple, but yeah, we need to be quite detailed and careful. Okay. Yeah, A times B. Let's see. Yeah. So the first thing is multiply the 8 with 108 times 100 plus second one 8 times 500 plus 11 times 200. Yeah, this is must be true because you see the pattern. It will result 1 times 1 order of matrix. So E times A times B equals to 800 plus 8 times 5 is 4,000 plus 11 times 200. 11 times 200, 2200. If you are not sure, then you can open and use your calculator. Yeah, 2200 or 2200. So the result of A times B equals to 800, 4,800 plus 2,200. 6, 4, 6, 7, 7,000. This is the result. Okay. One times 1. I forgot the bracket. This is the result. 1 times 1. So this is the result of total revenue. 7,000. Let's see and compare with the answer key. So you can try to calculate or solve all of this problem, and you can check your result with this key answer. E is 7,000. So this is the total revenue. Okay. Yeah. Okay. So you can try to solve the other point, and the interpretation is written in this slide, total cost, profit. But that is the basic things that you need to know in matrix multiplication and the basic operation of matrix in addition or subtraction matrix. The next one is about determinant matrix. Determinant matrix, it is written with this bracket, one line straight bracket. Yeah. The requirement, square matrix, row equals to column. So must be in square shape. This one is 2 times 2. So the number of row must be equals to the number of column. 2 times 2, if 3, then 3 times 3, etc. And to count the determinant matrix of A is very simple. You just need to multiply this part A1, 1, row 1, column 1 with row 2, column 2. And then minus it with the other way of value. A1, 2 with A2, 1. And find the constanta of this result. Nah, determinant matrix, one of the objective is to discover the matrix, whether it is singular or non-singular. So to define the singular matrix or non-singular matrix, we can see from the value of the determinant. If the value of the determinant is 0, then the matrix is called as singular, which means that matrix has no inverse. No inverse. But if the determinant is scalar, it can be positive or negative as long as it has a constanta or number, then the matrix will be defined as non-singular matrix, or it has inverse. If it has determinant, then it has inverse. If it has inverse, then we can calculate or find out the inverse of the matrix. We have the formula of the inverse matrix. This is the formula of inverse matrix. But before we discuss or learn about inverse matrix, I just want you to learn about determinant first. So the determinant of 2 times 2, we can find the result of the matrix 2 times 2 determinant. It also happened with the 3 times 3 matrix. The determinant is simply this part, you just multiply it. So if we have a matrix A, then you can type again this part, the two first column, as the value to help us easier. This is just a copy, like a copy 2 column after the third column for 3 times 3. And then multiply it, the right diagonal, A1, 1 times A2, 2 times A3, 3 plus A1, 2, A2, 3, and A3, 1. Plus again with this value. A1, 3, A2, 1, A3, 2. And then minus it or subtract it with this part. A1, 3, A2, 2, A3, 1. 1, 3, 2, 2, 3, 1. Minus again with this part. Circle A1, 1, 2, 3, 3, 2. And the last one. 1, 2, 2, 1, and 3, 3. Then find the result. And that is represent the determinant of matrix. It's very simple. Now we are going to talk about inverse matrix. If the determinant is k or constanta or scalar, non-singular, it has inverse. The inverse matrix, this is the inverse matrix. We have the formula to calculate the inverse matrix. A power by -1, this is called as inverse matrix, equals to 1 divided by the determinant times adjoint A. Adjoint is transpose of cofactor. Cofactor itself is a minor element of matrix with sign. And the sign depend on the row and column because the sign in minor element is derived from this formula, -1 power by m plus n. We are going to try this after we see the adjoint, the easiest way to find the adjoint. In your high school, maybe you also learn or have learned about it. So if you have matrix A, B, C, D, then adjoint A, simply change the A and D and add the B and C with negative sign. So if we have an example A equals to 5, 2, 4, 3, then swap the 5 and 3, become 3 and 5 here. And B and C, just keep it and add my negative sign in front of it. -2, -4. So this is the result of adjoint A. But it is impossible to use this method in 3 times 3 or bigger order of matrix. But I think I want to explain to you how to calculate the adjoint using this way. Okay. So I just bomb it first. Clear it, clear the board. And now I am going to use this one. So if we, just compare the way we are going to find adjoint step by step using this procedure, minor, cofactor, and then find the adjoint with this part. The result must be the same, but this is how actually we generate the adjoint. So if we have A matrix 5, 2, 4, 3, then if we are asked to find the adjoint, what is the adjoint? Adjoint, then find the adjoint of A. The first one, we need to find out the minor element. So find the minor element. And then give the sign to make it as cofactor. And make it as cofactor. So minor with sign. Firstly, I would like to ask, to teach you how to create the minor element. So this is the minor. So in this case, just want to type one more time. So 5, 2, 4, 3. This is the matrix 5, 2, 4, 3. Because they are 4 part. 3 and 5, 2, 4, 3. Okay. This is the way we find the minor. So to fill this part, row 1, column 1, this is, we just choose and make a line. This is 4. Yeah. And the value left, this is the result of this number or this minor. So the minor will be 3. The number that is not covered by the line. So for this value, row 1, column 2. Row 1, column 2. Just write it, and this is the value 4. This is also happen for this one. So 2 is in here, and this is the way. 5 is in here. So the result will be 3, 4, 2, and 5. Oh, wait a minute. Let's make it a bit clearer. Okay. So this is number 3. 3, 4, 2, 5. See, this is the minor element. And then the cofactor is the minor element, this one, but with the sign. The sign is derived or generated with this formula. See the formula. -1 powered by m plus n. M is row, n is column. See? So in this case, if I write this one, so this is row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. This is, so the m plus n is 1 plus 1. So this is 2, 1 plus 2 is 3, 2 plus 1 is 3, and this one is 4. Orange. So this is the m plus n. Okay. Then the cofactor is has the formula -1 powered by this number, -1 times 3, -1 times 4. So it becomes, the sign will be, okay, yeah, just use it. -1 quadrat, -1 times -1. So the result is plus. -1 times or powered by 3. Minus times minus plus times minus. Minus, this is also minus. -1 times 4 is plus, positive. Then put this result sign in this minor. So the cofactor, yeah, put it here, plus, minus, minus, plus. So the cofactor, here you go, this is the cofactor. The cofactor will be plus 3, minus 4, minus 2, and 5. Okay, we got the cofactor. And then cofactor is minor element of matrix with sign. And then we can calculate or find out the adjoint based on the cofactor with transpose that cofactor. So adjoint is transpose of cofactor. If we have this cofactor, then the adjoint of A is cofactor transpose of cofactor. We need to transpose it. 3, this one is row become column. 3 minus 4 and minus 2, 5. So this is the adjoint. 3 minus 2 minus 4, 5. Let's compare with the easy way to find the adjoint. Let's see. See this one. Wait a minute. I just make it a bit smaller. See, adjoint is 3 minus 2 minus 4, 5. So this is the adjoint. Yeah, it's very simple. If we have the adjoint and we know, yeah, we have the adjoint 3 minus 4 minus 2, 5. Okay, this is the adjoint. And how to calculate the inverse then? The first one, yeah, first thing to do is check first. We need to check. Yeah, just erase it. Okay. And to see whether the matrix has inverse or not, we need to find out the determinant of the matrix. Determinant of 5, 3, 5, 2, 4, 3. So the result will be 5 times 3. The result of determinant is 5 times 3 minus 2 times 4. 5 times 3, 15 minus 8. The result is 7. If the determinant has a scalar or equals to scalar, equals to 7, then it has inverse. And the inverse has a formula. A inverse equals to 1 divided with determinant times adjoint A. Adjoint A in English. So it is simply 1 divided with 7 times adjoint A. The result of adjoint that we already find out is 3 minus 2 minus 4, 5. So the A inverse, remember scalar times matrix. We just need to multiply it one by one. So scalar with this, with that, this, and that. So the result will be 3 7 minus 2 divided by 7 minus 4 divided by 7, 7, and 5 by 7. This is the result of A inverse. Okay, this is the A inverse matrix. Okay, we are nearly done. So the next one, we also can use matrix to solve the linear equation problem. This method, called as Cramer method, can be used to solve linear equation. Xj equals to A, the determinant of A, J divided with determinant A. This is an example. If we have this formula, this equation, then we can use elimination or substitution to find out what is the x1 and also the x2, the value of x1 and x2. But we also can use matrix, particularly Cramer method, to solve or to find the values of x1 and x2. So this is the way we translate or move this number. So the A will be 2, 5, 1, 3 times x1, x2. If we create this equation in matrix, it will be like this one. Just move this to here. 18 and 10, the result. Okay. Is it true? Yes, because 2 times x1, 2x1, plus 5 times x2, plus 5x2 equals to 18. And for the second row, we have 1 times x1 plus 3 times x2, 3x2 equals to 10. See? This is the equation. And this is the matrix that we call as A matrix. And this one is the result, or we call it as A, as the result. And the result will be filled in AJ. So this result will be filled, an example, if for A1, then the result will be filled in column number 1. So this is the A, 2513, 2513. Then we can calculate the number or the value of determinant of this matrix. 2 times 3, 6, minus 5 times 1, 5. 6 minus 5, the result is 1. So this is the determinant of A. And then we just type it one more time for A1. A1, so the result, we put the result in the column 1. For A2, we put the result in column 2. And for the other part or other column, we just type the value of A. 2, 5 and 3. 2 and 1, 2 and 1. In the first column, this is in the second column. This one. Yeah. So the most important, or the thing that we need to fill first, is the result, AJ. So A1 means the result will be filled for the column 1. A2, the result will be filled in column 2. And then fill the other or the rest column with the real value of A. 2, 1 or 5, 3. This one is 2, 1 and this one is 5, 3. Okay. And we use this formula. Xj equals to AJ divided by A. So for x1, it equal A1, determinant of A1 divided by A. x2 equals to determinant A2 divided by determinant A. So in this case, A1 means A1, this one. The result is 18 and 10, put it in the first one. 18 times 3, 54. 5 times 10, 50. 54 minus 4, 50. So it's 4. A1, determinant A. This one, put it here. And the determinant A is 1. 4 divided with 1 is 4. And for x2 is A2, the result of A2 divided by determinant A. This is the determinant A. 2 divided by 1. The result is 2. So the value of x1 is 4 and the value of x2 is 2. So we can use this one, Cramer method, to solve the linear equation, to solve or to find out the value of x1 and x2. Okay, you can try by yourself this problem 3 times 3 Cramer method. Use the way you find out the adjoint using step-by-step procedure to find the adjoint and then find out the determinant of A. Simply calculate it using the determinant of A with 3 by 3. So in this case, if I create this in the matrix form, then the matrix will be like this: 1, 3, minus 2, 2, minus 4, 1, 5, 2, minus 4, times x1, x2, x3 equals to 17, minus 16, and 21. Then you can use Cramer method to solve or to find out x1, x2, and x3 using A1 divided by determinant A, A2 determinant A2 divided by determinant A, and determinant A3 divided by determinant A. Then you can find those 3 values of A. And this is the last model or last implementation of matrix is in input and output model. It will be given to you with the other material. So please wait and you can learn about input and output model. But basically, input and output model actually refers to the inverse matrix. So we learn about how to solve inverse matrix. Then I believe that you can solve the input and output model based on the inverse matrix. That is the end of this matrix material. You can learn the details based on the slide of material that I will be shared to you and supported with this video tutorial. So stay safe, keep your spirit higher and higher, enjoy your study from home, and God bless all of you. Bye-bye, everyone.